of error.
Is that number 1, yes?
Yes, that's what I put.
Okay. We looking at number 1 of the preparation assignment. Yeah, I got a confidence interval is an interval of numbers which estimates a population parameter.
Yep.
That's what I got.
Perfect. Alrighty.
Number 2, I got
Primero dos.
what is a margin of error in a confidence interval when estimating the population mean? Write the formula and explain what it means. So the formula is like m equals z times sigma over the square root of n.
Yes.
And I said it's half the width of the confidence interval. In other words, the distance between the point estimator and one of the bounds of the interval. So like a point estimator is a variable we've been using, like a sample mean or a population mean or whatever you want to call it. Those are point estimators. It's basically the bounds of one of those.
Yes. All right. Let's see. All right. Assuming you know sigma, what is the general formula for confidence interval used to estimate the population mean? Now this is where we do the x bar plus or minus the z times sigma over the square root of n.
Yes.
Yeah. Right.
Or x plus or minus m.
Yes.
That's what I said.
That would be an easier way to put it.
But yes, that's the same thing. 4, what are the assumptions for creating a confidence interval for a single mean with a sigma known? So there's 3. SRS and SRS, or a simple random sample drawn from a population. 1. 2, x, the sample mean, x bar, has to be normally distributed, or through the central limit theorem, the size has to be large, over 30.
Yes.
And rule 3, sigma has to be known.
Yes. Or is approximately known. I think is okay. Perfect. Let's see. Open up your applet. Okay, so this was just having us do the ones that they already told us what they are. So for 0.9 is 1.65, the z-score. The positive z-score is anyway. Okay. B is 1.96.
Yes.
For 99% of the area is 2.58.
Yep.
What happens with the z-score as the area in the middle under the normal curve increases is that the z-score also increases.
Got that as well.
Alrighty.
We understand how that works. I mean, I know how it works, but
yes, you know, it took a little bit because it feels like as the percentage goes up, I want what part was it that I had a hard time with? I think like number 10 on the part 2 was the one that I had a hard time with, where it's like how the margin of error and the confidence interval.
Yes, I had a hard time with that one.
Did you have a hard time? Okay, we can do that when we get to it, but that's the part that I had a harder time with.
Yeah, it took me a little while to kind of let it register, but
yeah. So it makes sense for the ones we just did. It makes sense though, because your z-score obviously gets larger as you take more area, but you also get more of a chance of the mean that you're looking for being in the area because it's you take a larger area. So. Okay, and number 6 I think is the same answer as number 4.
It is. It is the same as number 4. I just wrote same as number 4.
That's what I put. I said C number 4.
All right. Graduate Management Admission Test, GMAT, is used as an admission criterion in many master's businesses. So after figuring out all of the stuff, what is the point estimate for the population mean? X bar is equal to 541.
Correct. That's what I got.
That you can find out by reading. Create a 95% confidence interval for the population mean. So you plug in your margin of error for both sides, and you find out that the answer is 549.87 on one side, the right side, and then on the left side is 532.13.
Yes, that's also what I got. Let's see, if you change the sample size to 100 and can get the 95% confidence interval, I got 534.73 and 547.27.
Exactly.
Yeah.
Got that as well.
Okay. Perfect. All right, so here's the one. How does the margin of error for the 95% confidence interval of the sample size compare? Oh, you know what? I think I read this wrong. Now I get it. The
Yep.
margin of error decreases as your sample size increases.
Yep. The margin of error
Yeah,
gets smaller than the original 50.
right, because you become more, it becomes, um, it's kind of like, like last week where if you, the larger your sample, the smaller your standard deviation. It's kind of the same.
Uh-huh.
Okay.
Yes.
Okay.
Now 11 is create a 90% confidence interval from the original 50 students. 533.53 is the left bound, and then the right bound is 548.47.
Yes. Also what I got. Let's see. How does the margin of error for the 95% confidence interval that you computed in part 2 compare to the margin of error for the 90% confidence interval that you computed in part 5? Let's see. So the margin of error, either it increases with an increase in the level of confidence or it decreases with a decrease in the level of confidence.
Yes, I got
So
that as well.
let's think about that for a minute. This one was harder for me to get in my head too. Um, so the confidence interval compared to the margin of error.
Basically, it's asking when you have a 95% confidence interval, how does
Mm-hmm.
that look compared to the margin of error of a 90%? Well, it's going to be like the higher percent, the more confident you get with your data, the
Uh-huh.
bigger your margin, the more confident you get, the bigger your margin of error. So like if you get, what's the word? Um, it kind of makes sense. Like I think of it, the less confident you are, the
Mm-hmm.
the the less confident you are, the smaller your margin of error.
See, I would just think it's the opposite.
Yeah, see, I wouldn't think it's the opposite either. Like it's kind of tough to
Yeah.
register. Like the more I'm confident that this calculator is black,
Mm-hmm.
the less my margin of error is going to be that I'm what I'm saying is right. So I'm
Is it more kind of like the same
trying to think of it as
as
like
number 10 where you're increasing the standard deviation, so you're making it a larger area, so then you also increase the chance of having an error? Like, is it
I
kind
don't
of like that?
I don't know if I don't know if I'd try and confuse standard deviation relationships with this guy
Okay.
with margin
This
of
thing.
error just because margin of error is like mm,
Mm-hmm.
it's a different equation.
Right.
Different equation
Right.
than standard deviation.
So margin of error. So you're less confident. No, you should be more confident at 95%, right?
The more
It,
confident that you are, the
uh-huh.
the larger your margin of error is going to be.
Right.
The way I look at it is like the applet graph. So think of
Mm-hmm.
the bell-shaped curve, and I
Yes.
think of the bars, and
Yes.
I think like, okay, if the bars are going out like farther away on the bell curve,
Yes.
um, my margin of error is going to be larger, but I'm going to be more
Right.
confident in saying, okay, like this many people, like 95% of the people are going to think this, are going to have this number.
Okay.
But if my bars go closer to the mean, my level of confidence is getting smaller and smaller and smaller. In other words, like I am like 50% confident that like the people will think this number. So,
Okay.
so like the closer I get to the mean, the closer to zero of confidence I'm getting.
Okay. Okay. I think I get it. I think I get it. It's kind of like it's just a weird thing to try and get your
It's
brain
a little
to
tough to
grasp.
kind of register.
Yeah, it is. Let's see. So number 13, the BYU professor would like to repeat it. He wants to find a sample, how large a sample should be for a margin of error of 5. So I'm sure there is an easier way to do this, which I'm sure you probably know. But I plugged it into the m equals z times the, standard deviation by the square root of n and got
Uh-huh.
158. But is there a simpler way to do that?
in the reading there was a equation they gave you that helped you solve for the number of the sample
Oh,
size.
so they
What they
just did
did,
the work for
yeah,
me.
they did the work for you. They did the algebraic numbers so that you could get an
Oh,
equation saying, okay, this is the equation
okay.
to solve for a sample size. If you wanted to know how many people do I need to
Right.
sample in order to find a margin of error of this and an
Okay.
accuracy of this. So that
Okay.
you can go look it up.
I just did the
I did
work.
it, but it's the same
Okay.
kind of way. They just kind of made it
It's
easier
the
for
same
you.
thing. Yeah. See, I just was like, multiplying by the square root of n on both sides, because it was a little tedious.
Yeah,
But I
it,
mean, I
it,
still got there.
that's no biggie. I
But
understand. I was like, there's gotta be some easy way.
yeah.
It's like I found it while reading, and I was like, oh, this will probably come in handy.
Yeah, absolutely.
It's
Absolutely. I should have written that one down. Well, that didn't take very long, Josh. Are you wanting to just take the quiz and be done, or do you want to go through some of the homework?
um. I mean, I'm good with the homework. If you want to take the quiz right now, if you don't mind, I'm good.
I think I'm good too. I mean, I kind of wanted to save some of my homework right so that I could do it right before I take the homework quiz in the morning. That way it's fresh in my mind.
Oh, sure. If you want to, go ahead and do that.
Yeah, we'll just take the quiz now. Let me open it up.
Take the quiz.
Level 10, group meeting.
Okay, group meeting.
All right.
Let me get some. All right.
Okay.
All right. Okay. They want to find. Are you? You open it
I'm
up yet?
ready. Yep,
I'm
I'm
ready.
on number 3.
Yep.
Find the margin of error for 90% confidence interval. Okay. Let me get to my.
So if I remember, the margin of error
Yeah.
m is equal to the z times sigma over the square root of n. They give you 90%.
Yep.
So 90% is 1.6.
1.65 times 50 divided by square root of 25.
Okay. Square root of 25 is 5. So
Yep.
1.645 times 50 divided by 5 is like,
10.
yeah, I got 16.45. Did you get that?
I got 16.5.
Oh,
Oh, did you round differently
yeah, I
on
rounded. I didn't round to the
yours? Or
nearest hundredth. I
you?
did the thousandth.
Okay, which is 4 5. What is it? 450? 16 point
1.645.
1.645. All right. So it's 16.45 is the margin of error.
Yep.
Okay.
Find the margin of error for the confidence interval with the standard deviation. Round to 3 decimal places. So I got 16.450.
Mm-hmm.
That's what I got.
That's also what I got. Okay.
Um, which of the following statements is true? Use a point estimator. It's an interval estimator.
X bar is a point estimator, which is what I think it is.
I think X bar is a point estimator of U. What is the
That's what
definition
I
of
think too.
point estimator? Here are my notes.
Mm-hmm.
They are point estimators because they are just one number and used to estimate a parameter. So a parameter is
Yes.
definitely a mu, like a
Mu.
population.
Yes.
So
Agreed. I think it's C, the third
it
one
is
as
C.
well.
Yeah, I say it's C.
I do too.
Gilda wants to construct a 95% confidence interval for a GMAT score. She knows the standard deviation. She collects a random sample size.
Okay. So her X bar is 526 minus.
Okay. 95%.
Okay.
All right. So Gilda, what is the lower limit? What is the upper limit? I made a program for this.
Oh, nice.
Yeah. All it says is the program basically states, oh, like, to do this. So what is X? X is 526, right? Z
Mm-hmm.
is, that's the hard part. You got to find out what Z is. Z is 95% confidence, 1.960.
Mm-hmm.
Standard deviation is 113. And your N sample size is 64. Got it. All right. Got my answers.
All right, I'm almost there. You're obviously much faster than me.
No, that's because when me and my roommate were in college, we made,
Uh-huh.
like, he was a programmer, and he would always, like, we were in math, he would always come up with ways to try and invent or make
Oh,
programs in
nice.
the calculators to try and
Uh-huh.
solve for every single question the teacher would throw at us. Because we could use our calculators. I mean, it was not like, oh, you can't use your calculator for this problem. It's like, no, you haven't. So we made programs in the class. Like, him and me would have competitions. Who can make the better program? Like, oh, I can do this
Nice.
one. Oh, you can't do that one. And so
Perfect. Well,
kind
that
of
would be
rubbed
nice.
off on me. All right.
Well, that sure saves time for sure.
Oh
All
yeah,
right, so the lower limit I got 498.315.
I got that.
Okay, 498.315. And what did you get for the upper?
I have 553.685.
Yeah, that's also what I got. 685. Okay. What happened to the width of the confidence interval if Gina increased the sample size? So it would decrease, right?
I'm trying to find it. What we said in our notes. What would happen to the width of the confidence interval if the sample size increased? I would think
It
it
would
would.
also increase. Is that the one? Is that number 12?
Um.
No.
Oh, I don't know.
Oh, it's number 10.
It's number
How
10.
does the margin of error? No, this is margin of error, confidence interval. It would also increase.
I would think it would. Well, I would think it would increase, right? I mean,
Mm-hmm. Because it's getting wider, because instead of 90% under the bell curve, you've got 99.
but they increased the sample size, right? It's not the confidence interval.
No, it is the confidence interval.
Oh, it is.
Yeah.
Okay.
What
What
would
would
happen
happen?
to the width of the confidence interval if Gina changed it to a 99% confidence interval?
It would increase.
It would
Definitely.
increase.
That I
That's
do
what I
know.
think too. Yep.
So if she increased the sample size, the width increases.
Yes.
But if she completes the 90, that I understand. I understand 8. It's 7. I'm kind of like,
Oh, number 7.
yep.
Oh, I skipped 7. Oh, hold on. What would happen to the width of the confidence interval if she increased the sample size? That would decrease,
Sure.
right?
I have no idea.
Because if you increase the sample size, you're going to be multiplying it by a smaller number because you're dividing the standard deviation by a larger number, so it's going to be smaller.
I would hope so. I would think so, right?
I would think so as well.
Margin of error. The margin of error is the width of the confidence interval, right? So
Hmm?
if you um, sorry, I'm just looking here.
No, okay.
I'm using the applet in the equation. So let's say 526. And I say Z is uh, and I say ends 100. Let's say
Hmm.
confidence width gets smaller. It says. Well, it shows that it gets smaller,
Hmm.
so it decreases, right?
Yes,
Okay,
that's what I think it is.
that's what I think too. But okay. Okay.
Okay.
Bright Bulb Light Company is planning to study average life expectancy of their light bulbs. They know standard deviation. They want a confidence interval of 95, and they estimate the margin of error is 50. What is the sample size? So it's n again. They want to know n.
Okay.
N is equal to so 95%. That would mean
Yeah.
1.96. Margin of error of 50 hours.
All right. Tell me
Yeah.
when you've got your
I
answer
got.
here.
Did you get an answer?
I got 174.
174. That's very different than what I got.
What did you get?
I got 246.
Okay, hold on. Let me see what I did. The
How
margin of
I
error is 50 hours, right?
50-hour margin of
90,
error. Not
95% is 1.645.
point. I got 1.96 is 95% confidence interval.
Oh, is that what I did wrong? Hold on.
Because 1.645 is
1.96.
90%.
Oh, shoot, that's what I did. Okay, 1.96. Let me rework this. Hold on. 506 equals. All right, 246. Is that what you got? 246?
And 246, yeah, because you have to round up.
Yep, that's also what I got.
Okay.
Thanks for catching that. Geez, I need to be careful. All
Yeah, no problem. Anytime.
right.
Help me out, you help me out.
Yeah, the beauty of a group, I guess.
Indeed. Um, let's see
Eight.
here. The mean salary of actuaries is that, and the standard deviation is that. You're interested in the mean salary for women actuaries?
Actuary.
Actuaries.
That is a job I would never want to have.
I
Those
don't
are
even know what
like
an actuary is.
statisticians. I think they're like statisticians. They're like they are like it's a math heavy. They work for companies and figure out the
They figure
mathematical
out
how to
like they
yeah.
figure out the math in companies. Oh, good grief!
Yeah, if
Never.
you're great at math, they pay a ton of money. They make a lot
Oh,
of
I'm
money.
sure they would. They'd probably
Yeah.
invest so much money into you if it meant that they would save $1 million on something.
Hmm.
Okay.
Oh yeah. I
So
mean, yeah, they make a ton of money.
we had to
All right.
use
Okay. Okay, so is this, let's see, you collect a simple random sample. What is the lower limit of this 95% confidence interval? Round to the nearest whole number. All right, so your X bar is 111,000.
Mm-hmm.
Let's see. It would be nice if I just memorized these formulas here. Okay, so they want the lower limit, so we're going to minus.
They want to know 95% confidence interval.
Mm-hmm.
95.
Which is 95 is the 1.96, right?
0.960, yeah.
Almost did it again. Okay, let's see.
Standard deviation was, sorry, 36,730.
Yep. Divided
And
by
how many sample size? 36?
36. Yep.
All right. Holy mother. That's a lot. Okay. 99,002. Bottom
Sorry,
number?
I'm still working on it here.
That's okay.
That's okay.
Let me know what you get.
Hold on here. I think I've worked this out wrong. I apologize. 36,730. Dividing it by 6. Times 6. All right. So what formula did you use? Did you use the x minus z times the standard deviation? What was the x bar?
Yeah, I used the equation we've been using all the time for to solve this one.
Mm-hmm.
Because they want to know the lower limit and the upper limit, so you're gonna use, sorry,
Do you use the
you
mean
use the margin of
salaries?
error. Yeah, I used oh no, I didn't
100,
use mean salaries. I used
111,000?
111,000.
Okay, that's what I used. Okay,
If I
so
wanted to double check it, I could do. No, but they want the confidence interval, the 95% confidence interval.
mhm.
They don't want like all the other information here.
So did you get the lower level to be $99,001, $2?
Yeah, what? I got 99,002 as my
Okay,
first, as number 10,
yeah,
and for
that's what I
11.
got as well.
Okay, and for 11 is the top part.
Okay,
I got.
shoot, I didn't write it down.
Go ahead. I got 122,999.
Yes, that's what I got as well.
Okay.
Okay.
I mean, I could double check it, but
Okay.
I think I'm pretty confident
All right.
with that.
You know what? Let me double check it because it just 36, 730, 36, 122, 999. Yeah. Do you round it up? Because I got like point 0.4, so like I got 122,998.
998.4667 is what I got.
Yes.
So I
And they
rounded
want
up.
us. All right.
I round-
Oh, just see. Hold on.
I rounded up to
I'm doing here.
120,989.
Okay. Yeah. So I got the same thing.
Okay,
I
I
just
think
put
we'll go with that.
122,998 though because 4 is lower than 5. So, well,
No, you always have to round up. That's the rule.
okay. I thought that was just for sample size. But 4.6 is, meh. Yeah, we'll do the same. Because it is pretty darn close. There are 3 requirements that need to be checked when computing a confidence interval for mean. Oh, these are.
Okay. Yep, the
All of the
answer for
above.
both is all the above.
Okay. Okay. The only thing I think I did different than you is I did 11, I put 122,998 instead of 999.
Okay. Um, I got the 999, and I would strongly recommend you rate that because I got 100.
Okay.
But you can go with what you said before.
All right, we'll go with what you said then. All right, thank you.
No problem.
Perfect. All righty, very good. I'll take the homework quiz in the morning and meeting Thursday at 11.
Yeah, Thursday at 11 sounds good with me. I mean, I have work these next few days, so I'm gonna be I gotta somehow drive and all this, and
Okay,
I gotta go plow too, so probably like already deep buried
perfect.
in there. I guess we have a mid-course
Yeah,
feedback, so I guess we gotta do that too.
yeah. That's just individual, right? We don't have to do it together.
No, we gotta do that individually.
Individually. Okay. Well, perfect. All right, we'll have fun plowing.
Oh, you too, Tabitha. I wish we could. I wish Natalie was here with us, but I guess she just couldn't show up, so we'll just have to see her later.
Yep.
I'll probably send her a text message or not a text message, an email again, and just let her know that we'll meet again at the usual time at 11. If not,
Okay.
you try and send her something too
Sure.
if just in case.
Yep.
But
Sure. I can do that.
I think that'll be all right.
Think so too. All right, Josh. Thank you.
All right, thank
Stay
you so
warm.
much, Tabitha. Thank you
Okay.
very
See
much.
ya.
We'll
See
catch
ya.
you later,
Bye.
okay? All
You
right.
what?
We'll catch you later then. Good luck in
Okay.
the snow.
Thanks. You too.
Thank you. Bye-bye.